Welcome to the class on artificial neural networks. This video gives a first rough overview over artificial neural networks as they are used for classification in layered feed-forward networks or in recurrent networks. So here we have a neural network. The input arrives at some input layer. Suppose you use a pixelized image. This is the input. And then the input is transmitted to other layers. Other layers, there might be 10 layers, there might be 100 layers, there might be 395 layers. And finally, it goes to an output. And so what you want the network to do is that it says, well, this input image is a car. So you present this input image, some neurons get activated. These are the red circles, others get mildly activated, the orange circles. And in the end, there is a choice of different output units, and one goes on very strongly, and ideally the one that goes on should be the one that represents the car. And then you present another image, it's again a car, so it's the same type of output unit goes on. And this, because of this feed-forward structure, it's called a feed-forward neural network. So it's really a flow in one direction from the input to the output. Instead of a car, you can use another image. And in this case, you want the network to say, well, this input image is actually a dog. So the aim of learning is that you adjust the connections, the weights of this network such that the output class is always correctly predicted by the neural network for each input, for each future input. So we adjust the weights during learning, during training of a neural network, so that the network does what we want on future input. And that's the aim of learning. So far we looked at feed-forward networks. Now with recurrent networks, you can do sequences. And one example I like a lot is this one here. So again, you feed a static image into this first layer, into this input layer of a neural network. It has several layers. They do the processing, and it also has these feedback connections between neurons. So it's really recurrent activity that can circulate. And this network has been trained to write a caption of this image. And so it says out, and then this caption is given to artificial voice. And this network says, a man sitting on a couch with a dog. I find this really an amazing example because you really get the impression, maybe falsely, you get the impression that the network understands what's happening on the image. To sum up this short video, neural networks for classification are often layered feed-forward networks, and if they have many layers, they are also called deep neural networks. But this is not the only network structure. You can also work with recurrent networks. Recurrent networks are particularly useful to generate sequences, temporally ordered words, for example, that make up a sentence. And during training, with a large number of examples, a very large number of examples, a recurrent network should be able and is able to a certain degree to pick up statistical correlations that in the end implicitly represent the rules of or the grammar of a language. In all these cases, it's the weights that are used as the adjustable parameters, and you can use you can train a neural network in a stationary classification task. Stationary means static input, static output, or you can also train it on a sequence task. Typically, you would use a recurrent network for that. And the details will follow in later videos.